But it's my job this afternoon to show you something a little bit different and hopefully to get you to think a bit. So first of all, I want to tell you where I come from, the Centre for Mechanised Mining Systems at WITS. We're part of the university, so we're involved in teaching and research, but we're also an industry institution. We're founded by a number of industry sponsors listed there on the slide, and our job is to get mechanization into mines. And when I say mechanization, I mean anything that takes physical effort away from people. So it can be as simple as a drill rig, it can be as complicated as a mechanical cutting system. We do three things. We do education, we do postgrad courses for graduate engineers. We're really looking carefully at systems thinking. We're trying to understand why mechanization succeeds or fails, and invariably, whether it succeeds or fails has very little to do with the technology, and it has a lot to do with the people and the processes. And finally, our job is to provide thought leadership, and so it's my job to talk at events like this, and if one of you walks away from here thinking a little bit differently about mechanization, then I'll have achieved my objective. So what I'm going to do now is I'm going to give a brief vision of the future, just give you a picture of what some people believe mining could be like in, let us say, 20 years. I'm going to bring it home to South Africa and say, well, what are we doing about it? Then I'm going to answer some questions, and these were questions that Duncan gave me before the day, questions that people ask about mechanization, and then if you have any more questions to answer, I'll be happy to chat to you later. So there are a lot of people who've looked at the future of mining, and I've picked one of them. It's the Swedish Rocktech Center, but their findings are pretty similar to Anglo-Americans' vision for their mine of the future, or Rio Tinto, or any of the kind of very forward-looking companies. And they see mining being several things, one of which is that everything will be controlled from a control room. In other words, we're looking at mining like a factory. So we have a control room where we understand the process and we run it like a process, like a factory. We have no humans in the production areas, and this is for safety. So all processes are remote controlled. Maintenance is done away from the production areas in a safe area, and there'll be no diesel underground. The future mine is a continuous mine. We don't want to stop and blast and get everyone out the mine and then put them all back in again and clean and repeat the process. We'd like to mine continuously, and this requires some sort of mechanical cutting. The pre-concentration underground has its advantages, and in mines where it can be applied, it means you pull out less waste to surface, which saves you energy. It also means you have to dispose of less tailings later, which are both important. To do this, we're going to have to understand what we're mining very clearly. So we're going to need to understand the mineralogy of the ore body, where the value lies, and how we can get that value out for least cost. We're also going to need to understand the structure, so that when we put in tunnels or excavations, they're properly supported and we don't have safety issues. And the final thing, particularly in a Swedish context, is a mine should produce no waste, so everything that comes out becomes something. Maybe the tailings end up in bricks. Ideally, they want to manufacture products on site. This makes a lot of sense in Sweden, and it's starting to make sense in South Africa, where you have new communities established in the middle of nowhere, and if you can put more activities around the mine, you can have a bigger and more viable community. So if that's the vision, what relevance does it have to us here in South Africa? I don't need to tell you this, we're under pressure. These are two headlines from yesterday's Mining Weekly. Productivity is going down. On the overhead, the curves are for productivity as measured by PwC for a number of countries. I want to point out two things here. The first is that South Africa is the bottom curve. There's a small consolation that Australia is second from the bottom. The second is all the curves are down, and they're all down about 30 to 40% off their peak in 2008. So around the world, there was a big focus a few years ago on production, and there's now a real focus on cost. And that's because mineral prices are bad at the moment. This is the platinum cost curve as generated by the Chamber of Mines. At the time that it was done, which was in the first quarter, you had about 25% of the mines above above the cost curve. We now have around about 60. So, you know, we're under pressure, there's just no doubt about it. It's the gold cost curve. Here, their idea of what constitutes the cost is perhaps not everyone's idea, but they're saying that just about every gold miner in South Africa is under the water. So what can we do? We've got to modernize. And I'm using that word because I really like it. It doesn't say mechanize, it just says think about things differently and do them in a modern way. Costs have got to come down. We've seen that safety is getting pretty good, so in a way that is less of a drive than it used to be, but it's still, safety has to improve. And we can benefit an enormous amount if we can move to continuous production. If you look at the time you spend out the mine for blasting, the time you spend out on weekends, the time you spend traveling to the face and back, all of these things added together, you're actually using the face about 30% of the time. If you had a continuous cutting system and you could work 24/7, you could push your face availability up to 100%. One of the answers is mechanization, and obviously that's the answer I'm promoting. And it's coming slowly into hard rock, but I have to say it's been done, and it's been done in South Africa, it was done in coal. So I'm just going to compare a conventional section with a continuous miner section. You're looking at 10,000 tons a week versus 15, 17 shifts a week versus 11, crew sizes of 30 to 35 and now down to 12 to 14, tons per man per shift, nearly 6 times as high. If we can see those kinds of movement in productivity, you know, then the cost graphs I showed you earlier become a little bit less of a problem. So that's kind of the global picture. It's kind of why we need to do it here. I'm not going to tell you how we're going to go about doing it. Many of you are in operations that are looking at mechanization, and you'll be aware of what's going on in South Africa. But what I'm going to do is I'm going to run through a few questions that people ask. Can it work everywhere? Short answer, no. Mines need to work as systems, and we've heard this earlier. You know, it's important that everything in the mine works together as a system. Introducing mechanization often involves a change in the system, and that may or may not be possible. So in old shafts, for example, they were sized for the reasons they were sized at the time. Now, if you try and put diesel equipment in, there isn't enough ventilation. Increasing the ventilation is very costly, and it may just not be worth it given the life remaining in the mine. Our ore bodies are tricky, you know this. Mining stopes down to 72 centimeters, as Frik was saying earlier. It's difficult to get a machine that works effectively in 72 centimeters. So we've got some challenges just to the straight idea of using machines in those areas. Our dips are inconvenient. They're not steep enough for stuff to fall on its own, but they're a bit steep for vehicles. And our rock is very hard. I did mention earlier that the coal mining, the number of people in a shift has come down quite a lot, but a lot of people then went into building machines. And the question is, can we build machines in South Africa? The answer is most definitely yes. On the right, Bell Equipment in Richards Bay. A huge operation, a lot of it's for export, most of it for open cast. On the left, Joy. Joy Global's an international company, but they manufacture machines in Germiston. How quickly is this going to happen? How quickly is mechanization going to come? The coal industry is just about completely mechanized. Where it's not mechanized, there are very good reasons why it needs to be drill and blast. And it's taken about 15 to 20 years to get that right. So mechanization is coming. It's probably coming, I would say, at 5 to 10% of the tonnage per year. So we're looking at perhaps 20 years to get it right, and we've been going at it for, I don't know, 5 to 10. It's coming, but it's coming slowly. There's a higher risk because you're changing the whole system. There is potentially a very high capital cost. These machines are expensive. And there's the system, the issue of changing the system. Explosives are pretty good, aren't they? Well, actually they are. They're a very, very good way of breaking rock. They're very efficient. If you use them properly, as we've heard a couple of previous speakers say, they can break rock very cleanly and very safely. But I have to show you this example. This is from London. It was cut using a mechanical cutter. It's about an 80 centimeter high chromite and 7,000 square meters without a single fall of ground. So mechanical mining can offer beautiful integrity and can improve safety. Much more tricky issue is the issue of seismicity. Effectively, when you take rock out of the ground, you leave a hole, the more rock you take out, the more stress builds up. When you do it with blasting, you do it once a day when you blast. That seismicity has a chance to get released in the period after the blast when there's nobody there. If you're doing it slowly, using a continuous miner, you're generating the same amount of energy that's going to need to be released, except now you don't have a bang that lets it all go. So controlling seismicity is going to be an issue for mechanization in deep mines. We don't yet know how we're going to approach it. Maybe we can go like coal and let it go behind the cutting. Or maybe we can do as Anglo Gold Ashanti is proposing to do, and put high-strength backfill in very quickly, so that by the time you cut your next section, the previous section doesn't even know there was a hole there. Labour. Indisputably, jobs will change. They will move. I don't think you can reasonably stand up and talk about mechanization and not say that. I think they'll move. They'll move from the stope face to the safe area underground, or to control rooms underground, or ultimately to surface if it's possible. And people will move out of mining and into the building of mechanized machines, building and supporting and maintenance. But I think what you have to say is people will be safer, and the jobs that they'll be doing will be more rewarding. There'll be less highly intensive physical effort, more mental effort, and potentially much more rewarding in terms of the kind of work people are doing from day to day. So in conclusion, there's just two things I'd like to say. The first is mechanization is coming, but not to all mines. The second is drilling and blasting is part of a system. I think people have said this before, but as a systems person, I'd like to emphasize this. If you do the drilling and blasting right, the rest of the system runs better. So it's really worthwhile concentrating on your drilling and blasting. And the third thing I'd like to add to all of this is you can introduce small amounts of mechanization to assist in your drilling and blasting, and there are people here today exhibiting that kind of technology, and it's worth taking a look at. So I'd just like to acknowledge all my sponsors and to ask if there are any questions.